Hi everyone. We're going to talk about transducers in this video, and remember, another word for transducer is detector, and this is where your detector is in a single beam instrument. And what does this detector or transducer do? Well, it's a device that converts incoming photons into an electrical signal, usually voltage or current. And there it is again, convert incoming photons into an electrical signal. We will talk about three different transducers: the photomultiplier tube, the photodiode array, and the charge couple device. If you're taking the lab, I want to say that the PMT was in probably the flame AA. You didn't use any instruments that had a PDA, but we do have an HPLC that has a PDA, and if you use the ICP, it had a charge couple device. All three of these transducers only work in the ultraviolet visible range, and in this video, we'll focus on the PMT, the photomultiplier tube. Here is a diagram of a PMT from your Harris text, and there's a lot to take in. I'm not sure if we're quite ready for it yet. Let's back up a little bit and talk about the photoelectric effect, and I'm going to do a little demo to show you what that is. Hi everyone. I thought we could use an analogy to review the photoelectric effect. Remember, in the photoelectric effect, photons strike a metal surface and eject electrons if those photons are energetic enough. So here's the analogy. Here is our photon, and if this photon is energetic to knock this book over, that means an electron was ejected. So I'm going to throw photons at this book and see if I can knock it over. Oh, not energetic enough. So now let me show you the difference between energy and intensity. Now what I'm going to do here is increase the intensity of the photon, right? How I'm throwing the photons at the book faster, but it's still not getting knocked over. I've increased the intensity, that's the number of photons per second, but no electrons have been ejected. If I want to eject an electron or knock this book over, I've got to increase the energy of the photon. Here we go. And now maybe I'll be able to eject an electron or knock over the book. There you have it. So again, in the photoelectric effect, we shine photons onto a surface, electrons are ejected, and in a phototube, that's what this is, a phototube, those electrons that get ejected are registered as a current. So what's the difference between a phototube and a photomultiplier tube? Well, let's see if we can figure it out. This is our photosensitive cathode, and again, that'll emit electrons when struck by photons, and that's a dynode. Just think of it as an electrode. And think of it as an electrode that's biased positive relative to the cathode. So here we have our incoming photons, an electron gets ejected, and because this dynode is biased positive relative to that cathode, this electrode is going to hit that dynode hard and eject even more electrons that strike a second dynode. Again, when these electrons strike this second dynode, even more electrons get ejected. So now I think you're getting the idea. What is the difference between a phototube and a photomultiplier tube is this multiplication of electrons that happens. So this process continues over and over again. such that for each photon, 1,000,000 electrons are generated. So the advantages of a PMT is that it's sensitive and fast, but there are some disadvantages. Sometimes these PMTs respond to heat, not light, just heat. So if you've ever used an instrument, you may have noticed that as soon as you turn it on, you hear a fan. And that's to keep it cool so that it doesn't respond to heat, and we like to call that dark current. And another disadvantage is that, yes, although it's sensitive, maybe it's a little bit too sensitive given that it can be destroyed by daylight. So that's the PMT. Hope you enjoyed the video, and thanks for listening.